That'll be tomorrow. We're going to talk about finding an AC problem here. No problem with that. This is the guy that I know that pulled up out there one day on his 2001 Cherokee, and he said that the air conditioner would work fine in the morning, but it stopped cooling after he drove it a while. So this wasn't just a dead in the water air conditioner issue. And so here's what we're looking at on our HVAC chart. And I can provide a copy of this. And this is something I put together. You might see a copy of it up here on the wall, or there used to be, I don't know where it is now. But anyway, the first thing you're wanting to know if your air conditioner doesn't blow cold is, does the compressor engage? I'm going to go out there and look under the hood, and I'm going to see if the compressor will engage. If the compressor engages, you're going to look at your pressures on the suction side and the discharge side. If the pressures are low on the suction side and high on the discharge side, you're going to basically look at your suction line. It's got to be, the suction line is the big line coming out of the evaporator. You'll see if it's cold, and the liquid line is the little line that's going back into the evaporator, and it's hot. It comes from the condenser to the evaporator. So you basically got the suction line going into the compressor, the discharge line goes to the condenser, and from the condenser the liquid line goes into the evaporator, and then it makes another loop. Okay, all right. So if you got issues with your pressure, not, you know, if your pressure low on both sides, like for example, if both gauges are reading low, you're going to be looking at your compressor health and your orifice and all that. So when you first plug in your gauges, you ought to see a static pressure. And there's not any good book numbers on this, and they don't always tell you anything, but whenever you got a static pressure that's between 70 and 110, you're probably pretty well okay. But I have seen it have like 90 pounds of pressure on both gauges. You know, of course, the gauges are scaled different, but if you look at the numbers, you'll see is they're going to be equal whenever the compressor hadn't been running. Well, when the compressor kicks on, the low side ought to start to drop down toward, you know, dropping down to close to 30, and the high side ought to be up around 150. In this cold weather, it's going to short cycle and everything because the ambient temperature's got everything to do with how the refrigerant responds. Okay, if your suction line is cold and your liquid line is hot, you're going to look for your heater slash blend door function. Like, for example, if you can be sure that you know which line is actually going into the heater core and which one's coming back out. If you pinch the line going into the heater core with a pair of hose pinching pliers and the air starts to get cold, you'll know you've got some kind of a problem with your blend door. If it's got automatic temperature control, you can actually go usually and give a, either use a scan tool or use the two buttons it tells you about to tell you if you got blend door issues. Now, if the compressor does not engage, you need to see does it have at least 60 psi of pressure, because it really should engage if you've got about that much, even if it short cycles. Does the compressor clutch have power? I'd either refrigerant, recharge, and retest, and then it gets kind of tangled up down here, but you can basically see how I put all this stuff together. And I'm not going to go over that in any more detail, but there is a systematic way you go through this. But you got to understand the electrical part of it and the way it works too. All right, this is an overview of the way the Jeep is wired up. Basically, you got your heater, your switches right here, and see A right here. Whenever you turn that thing on air conditioning, you're basically going to be putting power out over here to the AC switch sense on the powertrain control module, and then you've got these two separate leads coming up here. Now, right here you've got an AC high pressure switch, there's two switches in one, and down here you basically got a 12-volt feed that will not burn a test light. It's got a current dropping resistor in there, and as these right here, you know, open and close or whatever, you know, you're basically, you notice this was normally closed, that was normally closed, and you're coming up here. So as this flips over, it basically is going to lose the juice to the PCM, and it's going to know that you've got, you know, it's going to know what these switches are doing based on what these voltage is right here. That's not really all that complicated. We'll talk about that a little bit more in a minute. And there's your AC heater control. You notice you got the dotted box because you're not seeing the whole thing and all that. Radiator fan motor, it's got a relay there. They got an AC compressor clutch relay. That's an important thing to remember. And there's your AC compressor clutch relay control. They got this stuff all sort of down like that. Now here's where your AC low pressure switch is. This is your AC high pressure switch on this Jeep, and this right here actually hooks up to the compressor. All right, and then you got a this one right here, you got AC high pressure switch. This is actually with the fuse panel over there. This is the right front headlight, and this is forward, you know, pointing that way. Okay, and so basically you got, you know, you'll see us working over there. Now what I like to do here is I like to probe the switch signal, and so what I want to know is, am I seeing 12 volts there? With the meter connected to read power at the low pressure switch, you can see what the PCM sees. And this is what this is the reading the meter would show with the clutch energized, with a low pressure switch or high pressure switch is open. It just this thing. And in other words, I wanted the relay to still be able to do what it was doing. And so whenever I went into there and I touched the test light to that relay pin that was going out to the compressor clutch, it was still, I mean, it was energized in that circuit. And so the compressor clutch coil is good. If we take the, let me shoot that again. If we go right here, see the compressor clutch coil right here? If we take a test light and we hook it to power, and we pull this relay and we touch it right there, what should we see? We should basically see the test light light up, because the ground is going to go through the test light bulb to power. And if you touch the test light to that right there and it lights up, you know you've got a continuous path to ground, but you've got to unplug the compressor clutch to see if that ground goes away, because this wire could be shorted. So I have actually seen, here's another little short story. There was a lady that called me and she said, I've got a Nissan Altima, I think it was. It's like a 2010 model, and the air conditioner just quit working. Just totally stopped working. And she says, and I took it over here to such and such a shop, and they sent a kid out there, and he looked at a couple of fuses and he shined a flashlight around down in there, and he said, we don't know what's wrong, but we think it'll be $1,000. Which is, how would you like to be told that? We don't know what's wrong, but we think it'll be $1,000. And so anyway, she brought it over here. And what I did was I took my test light and I hooked it to power, and first I hooked it to ground, and then I went into that wire that goes down to the compressor, and whenever we turned on the AC, that light fired up. I said, okay, that's interesting. So I left the test light where it was and moved the lead over to, you know, switch everything off, turn the car off, but moved the lead over to the hot side of the battery, and the light did not light up. You understand what that means? What am I supposed to see here? If I connect the test light right here, and I've got it testing right here where the relay is, if that light lights up, and with your compressor plugged in, then you know you've got a good path to ground through here. If the light doesn't light up, either this wire's cut, or you got a bad compressor clutch. Now on that Nissan Altima, there was a bad compressor clutch. So we had to put a compressor in there, because the compressor clutch cost almost as much as the whole compressor. You know, and just changing a clutch is, you know, expensive proposition. So we put her compressor on there, and she got out of here for about $325 or something like that. All right, huh?
Beats 1,000.
Yeah, it does. But something else that I thought was interesting was there was another lady that called me the very next day with a different Altima, but it was still the same year model, and she was from a different town, which this other lady was from over here in Andalusia, and that lady was over from another town. But anyway, she said, my air conditioner quit working on my 2010 Altima, same song, second verse, different person, different car. And she says, and I went to a tire store over here, and they told me that it was going to be $1,000 to put a compressor on it. And I says, why are they charging you so much labor? Because the compressor doesn't cost all that much. He said, well, they said it was 6 or 7 hours labor. And I said, well, if you look it up in all data, it's 0.8 of an hour to change the compressor. It's not hard to do. Anyway, I don't know what she wound up doing. I mean, she didn't come over here, but I guarantee you she had the same problem. It was a burned out compressor. I also saw another one that was a Honda, one of the funky little Honda SUVs, and he had no air conditioner, and we had an open compressor clutch on it. I mean, we checked it at the relay, took the hot side of the test light, you know, test light, the hot side of the battery, went to the place that's leaving the clutch going out to the relay, leaving the relay going out to the clutch, and there was no ground there. And so that's telling us, you know, there ought to be a ground showing there if this is good. If this is a good ground, and this is a good, and that wire's not cut, you know, typically you'll see a problem if there's been a rat that's chewed the wire, you'll see something. Or if this ground on the other side is disconnected, a lot of times it's actually on the compressor where you can see it. So he had a burned out compressor clutch. And so we had to put a compressor clutch on that. So that's a real common problem, a burned out compressor clutch. Well, in this particular case, we connected that test light to that and it fired up. And then I said, well, and I felt kind of silly at the end of this thing. What happened, it turned out to be the air gap. The air gap on the compressor clutch, as this engages that hub, this is spinning all the time on a bearing, and this electromagnet pulls that in, and that's hooked to the compressor on the inside, and this basically spins the compressor. Now there are clutchless compressors that actually have a swash plate that moves on the inside that changes the operation of the compressor. But as this wears a little bit, it's not unusual for this gap to get a little wider, and it'll get wide enough to where that electromagnet is not strong enough to pull that in. And the way you find that is, if you find out you got power in your ground at your compressor clutch, it's what I should have checked first on this particular one. You take a screwdriver handle and you wrap it, whap. And if it clicks in and it starts cooling, and then whenever it cycles back out, it won't pull back in again, you found your problem. So his air gap had to be set. See what I'm saying? That was what was wrong with his. And I've seen that a lot too, even though there may be nothing else wrong anywhere else. But here's another thing. You cannot change this or that. You got to change them together. And typically, even if you're able to buy one, you'll get that, this, and this. Occasionally, you'll see this bearing go bad. And that bearing will make noise, or it can lock up. And I have seen situations where somebody thought they had a locked up engine, but when you take the belt off, the engine would start up because that bearing right there was locked up. This is a big pulley. Why do you put a big pulley on an accessory driven component, on a belt driven component? You basically, it's got to have a lot of power. It doesn't need a lot of speed, but it needs a lot of power and a lot of belt traction. So the air conditioner and this have both got big pulleys on them, because it's hard to pull those things. So you put a bigger pulley, it can handle it. If you put a little bitty pulley on your power steering, it'd slip. You know what I mean? Like if you were to doctor one and put a little bitty pulley on. The alternator, on the other hand, while it does pull some juice, it needs to spin fast to do its job. So you put a little pulley on it. And all that. But usually this one and the crankshaft pulley is going to be fairly close to the same size. They won't be exactly the same size, but they'll be close. All right, so Technician A says most of today's automotive air conditioning units use a thermistor in the evaporator housing to prevent evaporator icing. Technician B says refrigerant pressure is directly related to refrigerant temperature. Who's correct about that? Pressure and temperature are very closely related on an air conditioning system whenever you talk about refrigerant pressure. All right, so both of these guys are right. Thermistor in the air evaporator housing is really, really common. That Ford Fusion that we had in here earlier, it has one of those in it. In order to get to that, you got to pull the dash back out of the way, reach down in there and pop it out and put it back down in there. And there was another one that was a Hyundai Santa Fe. It was an 02 model that they never could, somebody never would. They took it to the dealer somewhere and they spent $2,000 or $3,000 putting compressors and all that junk on there, and it never would even get any air. And we basically punched the buttons on the, the way you do to get the codes out of the climate control, and we got codes telling us that evaporator thermistor was bad, so we pulled the dash out of the doggone thing, put one of those in there, and it worked just fine. But anyway, both of these guys here are right. Technician A says the 2001 Cherokee PCM puts out 5 volts from pin 22, while we're total 12 volts. Technician B says the Cherokee PCM puts out 8 volts, and neither one of those guys are right, okay? All right, which of the following would not cause the 2001 Cherokee evaporator to form ice? Now, if the evaporator forms ice, you won't have any airflow. Now this girl...
like on the outside of it?
Yeah, and I'm talking about the evaporator, you know how it sweats? Mm-hmm. Okay, if it keeps getting colder and colder and colder, it will actually turn into a block of ice and you'll lose your airflow.
What do you do when that happens?
It's because anytime you have a situation like that going on, like Gene Taylor's little pickup did it. He said, I drive down the road, I got air, and then I lose my air. There's no airflow, I can hear the fan blow, but there's no air. And so what we found out was the relay that drives the compressor was hung. And it was keeping the compressor on all the time. Now, on that Ford Fusion that I was talking about earlier, the control head on it is keeping the compressor energized all the time, even when it doesn't need to be. And it'll turn into, you can watch, if she just lets that thing run and as long as it wants to, ice will start to form on that suction line. It gets thicker and thicker and thicker. I mean, it'll get to where it's 1/4 of an inch thick if you just let it keep running. But on that, it's typically because you got a stuck relay or you got a controller that doesn't know it's supposed to release it, or something is not telling the computer. Now, on the orifice tube systems, you usually have a low pressure cutout switch that when the pressure drops below a certain temperature/pressure threshold, it drops the compressor out. The newer ones, for some strange reason, and years ago, they used to have measure the evaporator temperature with a little probe to turn off the compressor before it got too cold. Then they got smart for a while, Chevrolet and Ford and Dodge, and they would have a low pressure cutout switch without even measuring the temperature. You could infer what it was and it would turn off the compressor. But always look for a thermistor. Usually a thermistor will keep it from cooling at all. It won't let it freeze up. But if you've got a stuck relay or a controller or something that doesn't cycle the compressor off, or if something has happened to the compressor so that it's, pulling all the time, it can cause that too. An open circuit between splice 143 and the high pressure switch is short to ground anywhere on circuit C90. You'd have to have a schematic to do these. Stuck contacts in the compressor clutch relay are short to power on circuit C3. All I was telling you a minute ago was look for anything that's going to either have the relay closed all the time or the compressor clutch shorted to power somewhere so that it never turns off. That'll make it form ice. Alright, technician A says 2001 Cherokee electric cooling fan runs anytime the PCM sees the ground at PCM 1023. The electric cooling fan will not run unless the PCM detects the ground at PCM 1013. Suffice to say on that one, it's got a high pressure switch that when that high pressure switch gets close, it's in the high pressure line. If the pressure gets too high, it's going to kick on this electric fan that's a helper for the belt driven fan on that Cherokee. That Cherokee is one of the only ones I've ever known of that has a belt driven fan and an electric fan, and the electric fan is the one that kicks on when it needs assistance. Technician A says the compressor will cycle more often with a blower on low. Is that true? It'll cycle more often because the evaporator temperature gets lower whenever it's on low. If you want to get maximum cold out of somebody's register, put that thing on max AC and low blow, and that's where you'll get your coldest temperatures. Now we did that on that one, this girl that was in here that was a dual enrollment student had a Dodge pickup, and hers was giving trouble. And so she'd drive it and Riley would quit. And we put a thermometer in there and we turned it on low blow, and it got down to 30, 28, 29, 26. It just kept getting colder and colder because she had a low pressure cutout switch that wasn't cut. I mean, it was always closed. And that's all it took to fix hers, was a low pressure cutout switch. But you gotta be able to, you gotta look at a wiring schematic to find out how the thing is wired up so you'll know what to do. You know what I mean? If you just go in there guessing. Some of them have got what they call an amplifier, where it takes all of this information and processes it. It's a standalone module. It's not even connected to it's not even hooked into the engine controller. And the weirdest thing that I had ever seen, I'll tell about that another day, was one that it changed. I wrote an article about it for Motor Edge called Change Without Notice. And it was a Buick that we had to put a compressor on because it was leaking refrigerant. And we charged it up and let her drive it. When she came back, we found the dye and all that kind of stuff. But she had crazy stuff like the trunk ajar light was on, but the trunk wasn't ajar. The engine cooling fan wouldn't come on no matter how hot the car got, and all that. This is all kinds of crazy stuff going on with that thing. And on that particular one, we had some electronic problems, which we'll talk about later on that. Technician B says many vehicles will actually get better fuel economy with the AC on max or recirculate than well on norm. Now max is when it's pulling air from the inside and cooling it. So am I going to get better gas mileage on max or norm? On a trip between here and Atlanta, and the temperature is the same going both ways, if I put it on norm and I drive to Atlanta and I get 26 miles to the gallon, and I put it on max and drive it back to Atlanta in the same temperatures, which way am I going to get the best gas mileage? Why?
So we don't use as much, or would it really even matter?
It would matter because you'll get better gas mileage on max than you will normal, because you're air conditioning hot air that's coming in from the outside, and the compressor's got to run longer. See what I'm saying? So basically, you can infer that however you want to. Which of the following statements is true? A, the AC relay disengages the compressor clutch when energized by the PCM. No, on this particular one and on most of them, the older Fords used to energize the relay to kill the compressor, but now anytime it energizes it, it's going to throw the compressor in. The AC relay engages the compressor clutch when energized by the high pressure switch. Well, that's not true either. The AC relay engages the compressor clutch when the PCM sends 12 volts to the relay coil. Typically, the PCM will ground the relay coil, it won't send 12 volts to it. The AC relay coil is wired directly to the AC clutch coil. No, the relay coil is not wired to the clutch coil. So, which one of those is right? Depending on how it's wired up, this is the closest one to being true, right? Because that one right there, I guess if you wanted to pinch pennies, you could actually act like when you ground it, you're technically sending 12 volts, but most of the time that coil's got 12 volts to it, the PCM delivers the ground. Technician A says troubleshooting a problem in the 2001 Cherokee AC system requires the use of a scan tool. Technician B says the PCM has no control over the primary engine cooling fan. Now the primary engine cooling fan is driven by what on this vehicle? What did I just say? A belt. PCM got nothing to do with that one on that one. Of course, on the ones like that one laying up there, the PCM can control it even though it's driven by a belt to make it more closely match the speed of the pulley. Technician B says the PCM has no control over primary cooling fan, so you don't have to have a scan tool to troubleshoot the AC system in a 2001 Cherokee in most cases. Occasionally it helps because you can tell if you're getting an AC request signal and all that. Now this is not a test you're going to get rated on. Technician A says the secondary coolant fan on a 2.5 liter Jeep, which is a 4-cylinder, operates differently from the secondary coolant fan on a 4 liter. Technician B says the primary fan is belt driven on both units. No need to even go into that because these vehicles are old anyway and they're going away. Technician A says it's a good idea to check each and every automotive AC system with a refrigerant identifier. What do we say? Always check it with an identifier. You don't ever know what's in there. And we don't want to, it's like a disease or a virus or something whenever you just say, I'm just going to hook it up, pump the juice out, and let the chips fall where they may. Well, whenever you do that, you may be pumping a bunch of trash gas into your machine and then spreading it amongst everybody else's cars when you reservice your AC. All right. Technician B says if the vehicle is newer than a 96 model and has R134a fittings, there's no chance it will have R12. That's wrong. I've seen them with a mix, a blend. I've actually seen older vehicles with R12 fittings that had 100% 134 in them. And I mean, I'm sure somebody probably did something really slick on that. And finally, our Tech A says R134a is not flammable. That's wrong. It is flammable a bit. A lot of these refrigerants are flammable. They will burn, you know, if you torch them just right. Technician B says some aftermarket refrigerants contain hydrocarbons like butane and propane. And technician R is right. Technician A is right. R134a is flammable. But some aftermarket refrigerants do contain hydrocarbons like butane and propane. You know, whenever you're filling your butane bottle or whatever, how cold it gets. I mean, you know, technically butane and propane are refrigerants, but you shouldn't use them. Imagine what happens if you crash and all of a sudden your car fills up with butane or propane and then there's a spark. Yeah, so yeah, that's, you know, Smokey the Bear won't like it. So them kind of things. Anyway, all right. Yeah. Tell me something that you know now that you didn't know before I started this.
Thing about the gas mileage with the AC on.
Yeah, and you can sharpen your knife on a Craftsman wrench.
Yeah, but we didn't learn that. Craftsman wrench, you can sharpen your knife on.
You can sharpen your knife on a Craftsman wrench. He was saying, you know, you got a knife sharpener. I said, nobody got a wrench. He goes, huh? I went over and I ran that knife across that wrench a few times, and it was really sharp after that. You know, I learned that a long time ago.
You want to sharpen mine for me?
No, you can sharpen it. You know.